Hi, everyone. Thank you to Igor for the intro. And to introduce myself further, my name is Cole Bowden, and I'm a developer advocate here at Firebolt. I've been pretty hard at work running benchmarks for the last couple months to get some results to compare Firebolt to other cloud data warehouse vendors. Now, benchmarks can be contentious at times, and they do have flaws, but they're also really the only way to fairly compare different systems in a controlled environment. So we've done our best to be as scientific and fair as possible and to get results that we can stand behind and be proud of. As part of this initiative, we're actually publishing all of the data, queries, and clients used to run these benchmarks. And you'll be able to find that on the Firebolt website and GitHub if you go looking after Firebolt forward. So you should be able to reproduce this, but that's enough on that. And let's start talking about it. Real quick, before we get to the numbers, I'd like to discuss how we did it. So building the FireScale benchmark, the queries that we selected were selected from customers and users who were running queries in Firebolt itself. We selected 25 queries that ranged from very simple to very complex. Simple queries might be a simple select statement with a filter or two, whereas the complex queries may have many way joins and some CTEs. And there's one query in particular that's north of 300 lines of SQL. So they run the whole universe of possible queries, and we think that they represent what you might want to do with a data warehouse very well. The data set we used was taken from the UC Berkeley AmpLab benchmark data set. We did it at a terabyte scale, which means that the largest table in our data set was 1 terabyte. And we actually added a couple more tables to this data set to better simulate the way the real world works, because in the real world, you're not just querying data from 1 or 2 tables. In running this benchmark on different data warehouse vendors, we tried to be as consistent as possible. That means that we use the exact same queries, the exact same data ingested from the same source in the exact same region of US East, and using the same clients to run the benchmark. For our power run, we used a Python client, and for our concurrency benchmarking, we used a tool called Grafana K6 to better test and saturate the different engines or warehouses or clusters across these different vendors. So that's kind of how we set it up, and I'll get a little more into the methodology after we present the numbers, but let's get into them, and I can present first the performance numbers of the power run. So this is when we're running the 25 queries in the FireScale benchmark sequentially. Query 1, then 2, then 3, all the way through to 25. And as you can see from this chart, Firebolt is very fast. In fact, it's so fast that our smallest engine on this chart, a single node small engine, is faster than any configuration we tested on any of our competitors. So even a Snowflake XL warehouse could not achieve the performance of a Firebolt small, and that's despite being nearly 40 times the cost. Redshift and BigQuery similarly were significantly slower than Firebolt in this testing, and Firebolt maintained a performance advantage from around 4 or 5 times Snowflake to up to 15 or 20 times Redshift in certain configurations, and as well as about 4 or 5 times faster than BigQuery, depending on exactly what Firebolt engine you're running and comparing to. So we're very proud of Firebolt's performance here, and I think this benchmark demonstrates just how low latency those queries in Firebolt can get. Next, I'd like to talk about price performance, because Firebolt's engines in these benchmarks were actually less expensive than our competitors. We were running on our compute-optimized compute family, which means that a Firebolt small engine actually cost half the price of a Snowflake extra small engine, and that means that performance advantage from the previous slide turns into an even larger price performance advantage on this slide. Firebolt was able to run this workload both faster and at a lower hourly rate than our competitors, and that leads to a price performance advantage over Snowflake of somewhere around 8 times better, against Redshift of somewhere around 10 times better, and against BigQuery, because they're serverless, this isn't the best comparison for them. A serverless setup is going to perform better when the queries are spread out as opposed to run sequentially like this, but I believe the number is somewhere in the vicinity of 70 times better, which is really impressive for Firebolt. And again, that price performance ratio means that not only do you get better performance for those low latency and interactive workloads, but also you can get that at a lower price. Now, I'd also like to show this graph that does performance versus cost. So this is all of those slides, those past 2 slides, and all of those engine configurations presented in this scatter plot, where you can see Firebolt engines are consistently both faster and less expensive than those engines on Snowflake and Redshift. BigQuery we left off of this graph because the dot for BigQuery is like way below the bottom of the chart and doesn't fit on here and would have made the graph very squished if we had included it. So The next thing to talk about in terms of benchmark results is our concurrency results. So on this slide, we've actually controlled for engine cost. So the Firebolt, Snowflake, and Redshift configurations you see here from left to right all cost comparably the same amount. And on concurrency, you can see that Firebolt is simply achieving QPS numbers that our competitors cannot. So when you have high concurrency, many users submitting queries, and you need that high query throughput, Firebolt is able to achieve that far greater than its competitors. And as you can see, we're getting 2,500 QPS on a relatively large engine with 8 clusters. Another important thing to call out regarding this is that 2,500 QPS was achieved with a median query latency of 120 milliseconds. So it's not just that it's 2,500 queries being throughput per second, but also that they're happening in the blink of an eye, which is truly significant when you're using a user-facing data app or an AI application where you want to have many users accessing the data. Being able to handle that workload and get them the results back so quickly makes for a better user experience, and is part of why we think Firebolt is so good for this use case. So that's it for the numbers. I'd like to go back to that methodology slide just a little bit to talk about how this was set up and how you can run it yourself. So as said, we used a Python client to do the power run, which means that we were doing 25 queries in sequential order. We warmed up the engines with a couple queries to select the data and make sure that we weren't reading from cold storage. But we did that in the same way across every system. And then we measured the latency of queries client side. So that Python client was on an EC2 instance in the US East region, which is also where all of our cloud providers were set up. So we were minimizing latency and making sure that these results came as consistently as possible. For the concurrent benchmarking, we were using a tool called Grafana K6 in Node.js. And the way that worked is that you select a number of virtual users, and based on how many virtual users you have, they will all submit a query, and as soon as they have a result, they'll submit another query. We made sure to select a virtual users number that fully saturated the engines of each of the Firebolt and competitor systems. And we also tested to make sure that increasing VUs further wouldn't lead to either increases or decreases in queries per second, to make sure that we were fairly and fully testing each system and not leaving any excess hardware on the table. So we were able to do that, and that's why the QPS numbers you see actually scale quite well for Firebolt and Snowflake. They're both relatively linear here. It's just because of that performance and price performance advantage of Firebolt that it's able to achieve numbers that are far greater in terms of absolute values. If you have any questions about benchmarks, feel free to reach out to me directly, type in chat, or comment on the repository for Firescale on GitHub. We'd really like to hear feedback about this. We want to make sure that we are considering everything we can. And if you want to see us test other vendors or other systems, we'd be happy to do that as well. So thank you very much. And I'd like to kick it back to the rest of the squad presenting Firebolt forward. Thanks for your time.